Actually, this work was done a few years ago, but with the problems we had last year with Ripener because of Hurricane Ida, and also we had high starch at many of the factories early in the season, I thought it was very appropriate to give this presentation. I actually gave this work internationally, but I never have given it to the Louisiana area, so and the work was done with the USDA. So the presentation outline, we're going to look at the use of glyphosate and Moddus chemical ripeners in Louisiana. And then we'll also look at information on starch in Louisiana, why it's important. And then we'll go to the experimental section of the study, results and conclusions. So ripeners, like many other sugarcane producing countries, chemical ripener is routinely applied in Louisiana to ratoon or stubble sugarcane to accelerate sugarcane maturity and prolong the period of maximum stalk sucrose concentration. And as Dr. Ben Lejeune said in 2001, it is considered an important economic component of sugarcane management strategy. By far the most popular ripener used in Louisiana is glyphosate. And you can see at the top of this slide we have the chemical name, which I'm not going to pronounce. It's a plant growth regulator, and it works by inhibiting the growing point region, and you can see that it's pointed towards that. That's also called the apical meristem. It stops it from growing, but by stopping it from growing, then it increases the sucrose concentration. And here is a photograph where you can see this in action, where there's no ripener, the stalks and the leaves are much higher. With the ripener, you can see it shorter, and you also often see the leaves turning brown. So glyphosate chemical ripener in Louisiana, it usually means a decreased sugarcane yield and is known to reduce stalk weight. Typically, it's applied, it's only officially stated that you can use it for ratoon or stubble sugarcane at a rate of 5 to 7.4 ounces per acre. But this, of course, depends on the commercial formulation that you're using, and that has changed over the years. The treatment to harvest interval, so you treat it and you harvest later, and you can harvest 5 to 7 weeks after application. This is equivalent to 35 to 49 days. Currently in Louisiana, there's about 65% application of glyphosate. But the big thing to realize with ripener application is there's always a huge varietal response. Not all varieties respond the same to ripeners and glyphosate in particular. The other one that is used to less extent is called Moddus. It is also a plant growth regulator, but it works, has a different mechanism of action. It actually inhibits the production of a plant hormone, GA. And it's typically nowadays it's applied to ratoon crops at a rate of about 11 ounces per acre, and is often applied with 2.5 ounces of Power Max, which is a commercial glyphosate. And here you can see photos how it's ripener is often applied in Louisiana with a helicopter or a small aeroplane, but their backpacks are also used. So starch, we're looking at the effect of ripeners on starch in sugarcane. So let's just talk about that briefly. What is starch? Starch is made up of long-chain sugars, and you can see amylose, which is a linear long chain, and amylopectin, which you can see is branched. These are also, the long-chain sugars are called polysaccharides, but you can see they're packed tightly into a granule, which is very tightly packed and crystalline, very stable. And that's called an insoluble starch granule. And you can see next to it, there's a micrograph, a photograph of crusher juice, which we've stained with iodine. Iodine reacts with starch to give a blue-black color, and you can see The starch in sugarcane is very small, it's round, and it's usually 1 to 5 microns in size. But what happens in the factory and the refinery? There's heat, there's water, and there's time. So what happens is either the insoluble starch breaks down and releases those 2 polysaccharides, amylose and amylopectin. But with research over the last 10, 15 years, we also know that some of the insoluble starch does not break down, and some of it, a lot of it, it becomes swollen starch. And these, all 3 types of starch can have problems in the factory and the refinery. Problems associated with starch. This is a nice photograph. It explains it well. As I said earlier, starch, when you react it with iodine, it turns dark blue. So you can see this is a filter paper of 2.5 micron pore size. And you can see the soluble starch has gone through the filter. When we stained it with iodine, there's hardly any blue. Insoluble starch, there's some left on the filter. You can see those tiny dots. But look at the swollen starch. It doesn't go through. It's blocked the filter, and this is one of the problems of insoluble and swollen starch at the refinery. Just recently, 2018, we had an unusual year where we had low starch, and we correlated this, we related this to the TPD value, which is the target purity difference, which tells us about molasses exhaustion. So the lower the TPD value, the better the exhaustion. So you can see on the bottom axis as the TPD value increases, it's usually sometimes because of the higher the polysaccharide, and we know that starch is part of that. We know starch can cause TPDs to increase. And just recently at Audubon Sugar Institute, we actually took one of the polysaccharides in starch, we looked at all of them actually, and we found when amylase was mixed with fructan, which is another polysaccharide, we actually got a synergistic increase for viscosity. Now, what does that mean? It means typically if you mix them together, you wouldn't see a higher number than normal, but in this case we did, and we believe it's because there's some chemical reactions going on. So we know starch does affect viscosity. And we particularly looked at this study this year because of starch in 2021. As I said earlier, it was higher than normal. We have 3 factories here, A, B, and C. And so if we look at factory A, I just want to say, by the way, we used the USDA starch method, and the reason was because that method allows us to measure total, insoluble, and soluble starch. So some of these numbers are not what you're used to, but I do want to tell you this. Every month now, Audubon Sugar Institute gets a lot of raw sugars from around the world because a large international refinery group are sending us these. They're finding a lot of raw sugars are causing problems in refineries, and this method allows us to show the insoluble and soluble starch. So if you look at factory A on the 23rd of October at the top, you can see that the raw sugar, 31% of it had insoluble starch. And that's going to cause problems at the refinery. B, factory B on the 5th of November 2021, the syrups had over 36.8% insoluble starch. So you can add as much amylase as you want. You're going to have problems. And what we were finding there, some of these factories, they were adding a very, what I would call a non-concentrated amylase. Let's put it this way, it was about 40 Ecomza units in strength. A moderate amylase is 200, and a very good amylase is 400. But if you're adding only 40 Ecomza unit amylase, you're not going to be able to control that kind of insoluble starch. And you can see it reflected in the raw sugar where we had over 22% insoluble starch. Factory C on the 2nd of November last year, over 37%, again early in the season. Now Factory C, we got one from the 31st of October, and we found 19.7% raw sugar on average, whereas an equivalent raw sugar from the year before, 2020, was only 10%. So you can see we were dealing with higher starch and it wasn't solubilizing. So experimental on this study of ripener effects on starch. It was all done at the USDA Audubon farm, which Paul White discussed this morning. It was done in 2015 and 16. We had ripener application or treatments. We had glyphosate, 5.3 ounces per acre, Moddus, 11 ounces per acre, was applied with a backpack sprayer, and we compared it with a control, which was no treatment. The stalks were harvested 4, 5, 6, and 7 weeks after treatment. The sugarcane was hand cut as whole stalks, and you can see that on the photograph. For each variety, there was 4 replications, and each replication had 20 bundles, and you can see those bundles in the photograph, 20 stalks per bundle. Juice was extracted with a 3-roll mill at Audubon Farm. And in 2015, we looked at 9 different sugarcane varieties, Louisiana varieties, and here's the maturity, sugar per acre, and tonnage data. I just want to point out that after 2015, 233 was stopped being planted in Louisiana, which was a good job because it had extremely high starch values. So in 2016, we added some more varieties, and those ones that are actually shaded in red, we chose 5 of these 10 varieties where we looked at the analysis without leaves and with leaves. So since this work in 2016, 226, 371, and 613 are no longer used in Louisiana, but as you know, 299 is the big one at the moment, 283, and there's still some 540. The juice that was extracted, we measured Brix and Paul because we wanted to measure purity and the TRS. And as I stated earlier, we used a special USDA research method so we could measure total soluble and insoluble starch. So here are the results. So here is the TRS, and remember these stalks have no leaves. These are averages of 144 replicas. Results are the mean data for the 4 sampling dates. So in 2015, you can see TRS, the control, you can see that Moddus and glyphosate increase the TRS as you'd expect. But there was no significant difference. Now, 2016 was a better year for ripener. The sugarcane responded better to the ripener. There were, again, both Moddus and glyphosate, they increased up to 9.9% the TRS, and there was a significant difference with the TRS values with the 2 different ripeners. And also look at the precision values. Precision, so the higher the percent CV, the worse is the variation, and the lower, obviously, is the opposite. So you can see the glyphosate in 2015 and in 2016 actually reduced variation in the fields. Now we look at those 5 different varieties in 2016 without leaves and with leaves. And you can see immediately that the leaves diluted the TRS values. They were lower. But still, the Moddus and the glyphosate were better than the treatment. So leaves greatly reduced TRS and tended to increase variation. And the two ripeners had more effect on the stalk juice than on the juice from the leaves. But glyphosate was still consistently better than Moddus. And then here we have the TRS values with the different varieties. And you can see this is the 2-year data pooled. So you can see at the top is the best TRS values and at the bottom is the least. And you can see that sometimes we had significant differences with for the TRS values, looking at the capital letters, but sometimes we didn't. So it all depends on the variety. Brix, you'd expect ripener to increase Brix, and that's exactly what happened. Again, in 2015, we had about a 3.3%. Glyphosate was better. Remember, 2016 was a better year for ripener, and you got up to 10% increase with glyphosate. And you can see again that the control, the precision was better. And again, here we have those 5 varieties, no leaves and with leaves. And again, the leaves had a dilution effect on the Brix. But the ripener still improved the Brix markedly. Now we go to starch in the juice. First thing I want to show you is this. So in the blue is the control, the red is the Moddus, and in the green is the glyphosate. And you can see most of your starch in the juice is insoluble starch. And you'd expect that because we've not added, we've not heated it, we haven't given it time to swell. So that most starch in extracted juice is insoluble. And this is a good graph. It's the 2016 graph. It's the different varieties. In the blue is week 4, week 5 is red, week 6 is green, week 7 is purple. And you can see the different, if you look on the bottom axes, you can see control to Moddus and glyphosate G. And the big thing you see immediately is what a huge varietal effect there is. Particular 804 and 950 had very large starch values, whereas 299 is not bad. But look at the going from blue to purple. You tended to often go down week 5 and 6, but by week 7, the starch had really ratcheted up again for many of the varieties. And you can see visually some of the varieties had higher starch with the glyphosate addition. So what that tells us is it does make a difference on the when you harvest it after the treatment of the ripener. And look at the starch values here. You can see that both Moddus and glyphosate in 2015 and in 2016 increased starch. In fact, glyphosate in 2016, there was a 35.7% increase overall, but it was not significantly different, and that's because of huge variation among the varieties, huge variation among the weekly dates. The other thing I want to point out to you is look at the precision numbers, the percent CV, much higher than for Brix and TRS. So that tells us starch variation, even in the field, is very, very high. And is even, but in the good year 2016, the glyphosate actually in the Moddus slightly decreased that variation, but still extremely high. Now we look at the total starch results for the 5 varieties, no leaves and 5 leaves. No leaves and with leaves, right? And you can see we get the similar numbers for the no leaves, but again, the numbers were lower because the leaves diluted the starch. And I've been saying this for many, many years now. Do not underestimate the starch in the stalk because there's so much more volume and weight of stalk. You're bringing a lot of starch in with that. And again, you can see still high variation with the precision. And this is interesting. This is where we've pulled the 2 years of data, and you can see the variety effects. 233 at the top, you can see a huge increase in starch with Moddus and glyphosate. It's not being used anymore. Those varieties where I've highlighted it in red, that means that the ripener increased the starch. So if you look at 950, four down on the rows, you can see Moddus and glyphosate had actually it went down or stayed the same with 840. But with many of the other varieties, there was an increase. And I've highlighted 299 and 283, there was a slight increase there. But relatively speaking, these varieties have a lower starch compared to some. So major conclusions. Each year, Moddus and glyphosate ripeners significantly increased TRS and Brix and decreased the variation in the TRS and the Brix. So that was really great. Each year, both Moddus and glyphosate ripeners increased total starch from 20 to 35% on average, but this wasn't significant because of a huge varietal effect and possibly a date after treatment effect as well, and field variation as well. Variation in starch was high, and the effect of ripeners on the starch variation changed from year to year. And then factories may want to consider, if you're getting these high starch values at the beginning of the season, the cane's more immature, or you've had difficulty applying ripener, you may want to think about getting a more concentrated amylase, and maybe you just use it in the first month. You don't have to use it the whole season, but it would be one of your management strategies for starch. And while I'm not going to say that we have to breed for lower starch, it might be useful to give the factories a little bit of data on starch in different varieties. It might help them manage their cane as well. So acknowledgements. I'd like to thank the American Sugarcane League for funding this research, and also particularly the staff of USDA Audubon Farm for their help. Thank you.
We're a little tight on time, so we're going to allow one question of Dr. Eggleston. Any questions? Yes.
Gillian, when you said at the beginning when you started, when you had Moddus, was that 11 ounces of Moddus with half a rate of this glyphosate, or just 11 ounces?
No, it was just at that time we did that work at Homer. It was just Moddus on its own.
And the glyphosate was after 5 ounces of it?
Yeah. And I think Alice told me that some of the formulations have changed since then.
Our max.
But it was 11 ounces of Moddus only?
Yes.
Thank you very much.
All right, thank you.